Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Hello, folks. This episode of Lab Life is a special one. We had the chance to speak with Dr. Lloyd Tripp before his retirement to discuss aerospace physiology, AFRL facilities, and how putting people in a box and sucking the air out is an integral part of any pilot's training.
In 3, 2, 1.
Dr. Tripp, welcome to the podcast.
Well, thank you. I'm really glad to be here today.
We're excited to have you here today. You're a research lead for aerospace physiology within AFRL, specifically within our 711th Human Performance Wing. What do you do for a living?
Well, I'll tell you, this is one of the coolest jobs in all of AFRL because my job is to take people, test subjects, basically control the research that we're doing, run the research programs, and put those folks into the big box and suck the air out, or put them in a centrifuge and spin them around the room.
Hold on, I want to revisit what you said there. You said the big box. What is that?
Oh, the big box, that's the altitude chamber. Yeah, I'm sorry. Yeah, it looks like a big box. You have to just call it like it is. It's actually a little bit more complicated than that. So really what we're doing in the acceleration environment, in the centrifuge, is really looking at new technologies that are coming down the pike. So these are new technologies that will go into aircraft. We're looking at pilot cognitive performance. We're looking at things like the applications of breathing regulators and evaluations of equipment. And we do that in both of those facilities. So whether we're taking you up and simulating the altitude that an aircraft would be flying at, or simulating the gravitational forces that a pilot might experience during flight, that's basically what our facilities do.
And that's something we're going to dive into here in a bit, because something many folks may not realize is the very storied history of altitude-related research and working centrifuges, everything you mentioned, because it's critical to a pilot's life. They need to know what it's like before going up. So what you're doing there is not only truly integral, but from what I understand with AFRL, really one of a kind here.
It really is. And, although research in these types of facilities has been done for many, many years, they keep changing the aircraft that we fly, and then the parameters and altitudes and speeds and acceleration. And so these facilities basically help us keep up with the onset of new technologies in aircraft. But probably more importantly than that, I think that the facilities that we have today are much more technically savvy, if you will, than the facilities we've had in the past. And so I'll give you a couple of examples. So the centrifuge that we have today has an onset rate of 15 G per second. So what does that mean? 15 Gs per second means that in 1 second's time, you could be at 15 G from a dead stop, or pretty close to a dead stop.
Wow.
And then the maximum G capability of that facility, it's 20 G. So fortunately for the test subjects that we typically have, or pilots that come in for training, as the training section does their job, typically cap that around 9G, or 9 times Earth's gravity. So what does that mean to you and me? Well, if you take your weight and you multiply it by 9, that's how much you weigh at 9G. So my 200-pound pilot at 9G weighs 1,800 pounds.
Oh my gosh, sorry.
Just
That's
putting
just
that into
setting
perspective.
in. Wow. Yeah, I've heard it described in the centrifuge as almost having an elephant sitting on your chest. So it sounds like that's really the case. That's a lot more weight.
You definitely feel that weight. I was a test subject for 8 years in the centrifuge and had an opportunity to pull G more times than I'd like to think of. Matter of fact, in one of the evaluations we did of a system called Combat Edge, which we currently have in fighter aircraft, system had a little bit of an issue, and I ended up going to 9G 178 times before the problem was resolved. Of course, I used to be a lot taller too than I am today, but sometimes it takes that type of dedication and involvement to be able to figure out what the problem is, get it fixed, and then move on and get that system integrated into the aircraft.
So when I was a kid on the MerryGoRound, what kind of G's was I pulling, Dr. Tripp?
On the MerryGoRound, probably not very much, maybe about less than a half a G. But if you ride roller coasters, And I always when I have an opportunity, I always ask students at high schools when I go and give talks, I'll ask them, how many of you pull G like pilots in fighter aircraft? And nobody raises their hand. And then I'll ask, how many of you have been on a roller coaster at an amusement park? And depending on the age, most of them all raise their hand. And I said, well, then you've experienced the same gravitational forces that a pilot's experienced. Matter of fact, I said, when you hear that click, 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 you know what's coming next, right? You're up over the top and you're down and you're heading straight down towards the ground. And then you feel your body being pulled down and you're saying to yourself, oh, please don't let the bar that's holding me in place fail. And then just about the time you thought that, you were heading back up again. And about that time, when you got all the way to the top, it felt like your body was coming up out of the seat. Now you've experienced some less than 1G or negative G. And then as you came back around the corner and it did a really, really tight turn to the left and then one to the right, those were G-forces side to side. And then when it came to a stop and your body went forward, you experienced minus GX or back to chest acceleration. And when they launched you initially and it forced you back into the seat, that was positive GX. By the way, those are all the G-forces that could possibly occur in flight. And so if you've ridden a roller coaster, you have probably experienced those. And roller coasters, incidentally, typically about 5G on a really good roller coaster these days.
Well, I'll make sure then to keep that in mind. The last big roller coaster I rode, or a really impressive one, I'd say, was Diamondback. Not a sponsor, of course. But I was able to feel a lot of G's there. Didn't realize how similar my experience could have been to different pilots. But that does bring something to mind. So I did this when I was a bit younger, and I'm here now today. So I'd love to find out, Dr. Tripp or Lloyd, what brought you here then? Like in your childhood, we've had a lot of things that build up to this moment to make us these scientists we are. So what got your interest in well doing what you do?
Well, interestingly enough, all the way back into grade school, I really liked science. And I had this vision of being a research scientist, even back when I was in as early as third grade. I think I saw science shows on TV. At the time, a lot of interesting things were happening in the world in terms of space. And I thought, research would be really an interesting area to get into. And then by the time I was in fifth grade, they had this test that you took. And basically the test was to give you some idea of what you might be suited for as an adult. Now, how they can determine that in the fifth grade, I have no idea. But I took the test, and then it came back. And instead of it saying that I could be a research scientist, it said you would really be well suited in sales. Well, pretty disappointing. So then I talked to the teacher had asked the question, what did everybody think about the results of the test that you took? And I said, well, I wasn't too happy. I said I would really kind of had my heart set on being a research scientist at some point in time. And unfortunately, not very encouraging input back from my teacher, who said, I don't think that you could be a research scientist. And I said, why not? Thinking probably because the test said that you couldn't be. And he says, because I think that you're too stupid to be a research scientist. Well, that's kind of devastating. But nonetheless, you persevere and you push on. And, for folks who are thinking about what do I do, when I grow up, um, and you've kind of set your sights on something, don't let somebody else dash your goals and those dreams that you have. Push forward. And that's what I did. So I pushed forward and said, I think that's something that I'd like to pursue. And so I did. So science was really something that I studied relatively hard while I was in grade school and then further on and junior high. But by the time I got to high school, my first day in a life science class, the teacher called and says, can I see you out in the hall? And I thought, I wonder what I did. And so I go out in the hall and he says, why are you in this class? And of course, in high school, this is the first time that you're changing classes. So you're going to different rooms and those types of things. You're trying to get used to that. And I was panicking, thinking that I walked into the wrong classroom. And I said, I think I'm supposed to be here. This is life science. He goes, no, not the why are you here in this class? You're assigned here. He says, why aren't you taking biology? And I said, because they wouldn't let me take biology. And he said, I'm going to see if I can get you in a biology class. He goes, you need to be taking biology, not life sciences. So he came back and he said, I can't get you in a biology class, but what I can do, he says, I can get you in an independent study class in science. He goes, and basically you can do independent study in biology. And so I basically came up with experiments, and then I ran those experiments. And so actually it turned out to work out really nicely, because I basically did independent study in science for 4 years in high school, and got to work on things like tissue culturing and genetics and bacteriology and in the microbiology area. And so it was a really great experience. And then took physiology and those types of things. Had my sights set on going to pre-med. I said, you know what? I said, I think medicine would be a really cool area to go into. So out of high school, I was in a pre-med program, and then unfortunately ran out of money. And then said, what else could I do in the medical area that would really make me happy? And so I started looking around, and at that time I was working construction, and ran across a recruiter who said, if you are interested in medicine, he said, we've got multiple career fields in medicine in the Air Force. And so I said, well, what kind of career fields do you have? And so he said, well, you can be a medical technician. And he said, you can either work on the ward with individuals, like with patients who are admitted to hospitals or work in clinics. He goes, or you could work in aerospace medicine. I go, ooh, what's aerospace medicine? He says, in aerospace medicine, he says, you basically are helping the flight surgeon take care of pilots. So physical exams and medical exams of the pilot population, as well as the air traffic controllers and combat controllers, and anybody who basically had an aeronautical rating went to flight medicine. And I thought, wow, what a cool area to work in. So took the test, enlisted in the Air Force in 1977, and went in the Air Force and became a medical technician working in aerospace medicine. And so my first assignment was Norton Air Force Base in California. And they had C-141 transport aircraft there at the time. And so the squadron I was assigned to, the squadron commander said, you should probably fly with us, every once in a while, just to see what the pilots have to go through from a day-to-day perspective as both pilots and air crew, and what their jobs are, so you better understand when we come in off of a mission why we're not always in the best mood when we come see somebody in flight medicine, or kind of what the culture is of the people that you're taking care of, which was really a great opportunity. I flew all over Europe with them, places in the Orient, then to Australia and New Zealand. All those times that I did that, I always learned something new on a mission and got to know the air crew extremely well that way.
And what was your next assignment?
I was assigned to a fighter squadron in England. My squadron commander knew that I liked to fly, and so he somehow worked it out to allow me to fly in F-111Fs periodically with the fighter squadron, which was a great experience. I deployed with them. Anytime they deployed someplace, I was their medical support in the field, along with a flight surgeon and usually another technician. But it was really a great experience, because now I had an opportunity to experience G-force, and I had an opportunity to experience altitude and flight equipment and what those pilots went through on a day-to-day basis in flying in those environments. And all of those things that you do add up. It's kind of a cumulative learning experience that you can use someplace down the road. And I can give you an example. So one day my squadron commander says, guess where you're going tomorrow? And I thought, oh, we're going TDY someplace. We're going to go travel. And I said, so where are we going? He says, well, we aren't going anywhere. He goes, but you are going to go to fighter tactics course. And I said, a fighter tactics course? And he goes, yes. He says, when you fly with us, you fly in the weapon systems officer seat. And he says, and you should know what tactics we employ and why we employ those. And he said, so you're going to the weapon systems, you're going to go to the course to learn how we employ those things as a weapon systems officer. So I went to the course and thought to myself the whole time, I will never use this skill at all, ever. So fast forward many years, we're doing a project on the centrifuge. We have subjects flying the centrifuge closed loop. which means that they're in control of the centrifuge. And when you pull back on the stick, it speeds up. And when you push forward on the stick, it slows down. And you're basically tracking an airplane on the screen and then following that aircraft. And when your heads-up display says that you're at 9G, no kidding, you are really at 9G. And so my first test subject pulled 9G for 45 seconds, which is something you would never do in a fighter aircraft, maybe a couple of seconds max at 9G. And so I couldn't figure out, why did she pull 9G to catch the airplane? And then I realized she knew nothing about fighter tactics. We needed to take a step back in the experiment and teach our subjects about fighter tactics and how to catch that airplane and not pull 9G, maybe only 5.5G, much easier on the body. So I had an opportunity to apply the fighter tactics course that I took while I was at a fighter squadron directly to the research projects that we were running at the time.
Wow. When I step back and think about it, you said that you signed up for the Air Force in 1977. So we're really, climbing through 45 years of history that you've had with the Air Force.
Yes, absolutely. So I've worked for the Air Force in many capacities. So I started out enlisted. I was conducting research projects at the time. And then I got off of active duty and went in the reserves because I really enjoyed aerospace medicine and what I did. And when I joined the reserves, I had an opportunity to go to Desert Storm and support the air crew there as part of a deployed package to both Oman and then Saudi Arabia. And then I was in charge of medical operations in Oman and then at King Fahd Air Base in Saudi Arabia. While at the same time, I now worked as a civilian contractor for the Air Force. So I continued working for the Air Force. Of course, after Desert Storm was over and I came back, I continued to work as a civilian research scientist for a couple of contractors. And then eventually transitioned into civil service. So I've done all three things over the course of 45 years, all different experiences, and all things that I have just really enjoyed. Matter of fact, I would never tell my boss this, but I enjoy it so much I would probably do it for free.
Quite the history there. And during one of your active duty assignments where you were at a predecessor lab for AFRL, you actually earned the Harry G. Armstrong Award for Scientific Excellence. What was this award, and how was it a watershed moment for your journey?
Yeah, so that award was at the time was the top scientific award presented by the laboratory. And so there was a competition for that award. And typically the researchers who had cutting edge projects and had lots of experience doing research were nominated for that award. And my boss, working in the acceleration area, said, I'm going to nominate you for the Harry G. Armstrong Award. And I said, well, I'm really honored, to even be considered to be nominated for it. I didn't really think that I had a chance to win that because the competition for that, of course, is extremely stiff, right? Because I'm a tech sergeant in the Air Force competing against PhDs. Well, the only people that know are the commander and one person on his staff at the time in terms of who won the award, because the announcement is made at the awards banquet. And so when they announced my name, you can imagine I was in shock. Matter of fact, somebody had to poke me and say, I think that's you.
A friend like that helps.
Right. I really appreciated, that helped let me know that that was me. So the award was really set up for those folks who had cutting edge projects. And at the time, I was looking at lower body negative pressure for negative G protection. It was really an interesting concept because up until that time, there was really no protection that was developed that we could show that provided adequate protection from negative G. So negative G, the blood is basically shifting towards your head from your feet. And so if you've ever hung upside down on the monkey bars on the playground, you have been at minus or negative 1G. And so that sensation that you had of pressure increasing in your head, that's now multiply that times 2. And that's what it feels like to be at minus 2G. Some work that had been done in the past, they basically showed that if you could decrease the amount of blood that you had circulating in the system, that it would decrease the effect of negative G. Well, you can imagine that's very unpopular with pilots, right? Taking their blood and then reinfusing them again. So we thought about a way to put the blood someplace else temporarily. And what negative pressure did, when you put negative pressure around the lower portion of the body, the blood has a tendency of wanting to go where the least amount of pressure is. And so blood was basically pooling or collecting down in the lower extremities. And so when you went to negative G, you had less blood shifting towards the head. So how did we know that that worked? Well, we hung people upside down and then turned the suit on and then looked at the amount of blood that was coming back to the heart. And by doing that, we were able to assess the fact that the lower body negative pressure actually was effective in being able to protect somebody at least minus 1G. And then we took that to the centrifuge. So I built the lower body negative pressure suit on my desk. Matter of fact, I had a researcher from NASA call me up one day. And he said, we're looking at using lower body negative pressure on board the space station so that we can use that as a way to cardiovascularly condition astronauts during long duration spaceflight. And he said, and I understand that you have a suit that you developed that you can sit down in the suit and then have it work. I said, absolutely. I said, it's a very flexible suit. He said, well, I'd like to come out and see that. I'm going to be in Dayton in a couple of weeks. And I said, oh, that's great. So he came out to Dayton. I said, well, what you have to do, I said, is that you have to promise not to laugh. And he goes, why is that? And I said, because I built the suit on my desk. This was not built by ILC Dover for millions of dollars. So it may not look, as a finished product. I said, but the suit does work. We've had an opportunity to test it. So he came out, and he's looking at the suit, and he's feeling the material on the outside of the suit. And he says, well, what's this material made out of? And I said, this is Air Force raincoat material. He says, Air Force raincoat material? I go, yeah. I said, that's what the Air Force uses to make the raincoats out of. It's a neoprene impregnated nylon material. He goes, oh. He goes, well, how do you sew that? And I go, oh, you don't sew it because otherwise it leaks. But if you use contact cement, you can overlay the areas and overlap them. And I said, and have a perfect seal. And so then he says, what's this abdominal area made out of? And I said, that's made out of Kydex. So Kydex is a thermoplastic. And this is where the AFRL kind of works together. So I went for some advice to the materials lab and said, I need a material that I can form. And they said, oh, well, Kydex would be perfect. Matter of fact, we used Kydex at the time to make oxygen masks out of. And they said it has a very high structural integrity, so it won't collapse during negative pressure. So I built that out of Kydex. So then he's kind of touching the legs of the suit, and he says, so what are these leg sections made out of? And I go, drainage pipe. He goes, excuse me. He goes, what was that? I go, drainage pipe. He goes, drainage pipe? And I go, yeah, you're driving down the road, you see that black corrugated pipe, they use for drainage. And he says, do you mind asking me how much money you spent building the suit? And I said, well, I had to build two suits, if we have different sized individuals. But I said, I spent a total of about $500 on both suits. I said, it could have been a lot less, but they made me buy 100-foot sections of the corrugated pipe. So he said, so you have this suit, you spent about $500 building it. And he says, and does it work? And I said, oh, yes, absolutely. I said, matter of fact, I said, we've had it to over a minus 160 millimeters of mercury pressure. And he says, how do you know that? And I said, well, because I let our flight surgeon control the pressure, and he kept decreasing the pressure and decreasing the pressure. The suit was sucking me in. My vision was collapsing in. I could only see about this much. Had about this much vision. It's kind of like looking through a toilet paper roll eventually. And I said, and finally I asked him to get out of the way, and he was looking at the wrong gauge. So the gauge that he was supposed to be looking at was actually pegged at minus 160, and it pretty much stayed there because apparently it was more than that. But we proved one thing, and that was that the suit could definitely do what it was designed to do, and that was to go to minus 100 millimeters of mercury pressure for the actual experiments.
Oh, wow. What came out of that?
And as it turned out, although NASA wasn't able to use the structure because it couldn't collapse down small enough, they were able to use the outside material concept to build a device that ratcheted up and then locked in place, and then had the soft shell material, kind of like the raincoat material, on the outside of that to create a negative pressure vessel. And then they used that on the space station to do some research.
That's amazing. Uses some parts in a drainage ditch, and then, it ends up on the, space station. That's pretty amazing.
Right.
Wow. To follow up with what Michelle mentioned, I mean, that is incredible. The work you're able to do with the suit, ingenuity, and really connect with some brilliant minds. So, furthering that, though, I'd be interested to find out more of what you've done in the centrifuge. We talked about it at the top, but let's spin it back up, if you will. So, when you actually get someone through there, can you walk through what it actually does to you, what the centrifuge, like how it works, the mechanics behind it? You've been in there yourself, you mentioned, so I'd like to just get a personal experience for folks who may not know.
The centrifuge and the way that that works is there's a cab or a pod, if you will, that sits out on the end of an arm. And so in our particular centrifuge, that sits out about 31 foot from the point where it actually starts turning. So this big arm is turning around the room. The cab that you're sitting in actually gimbals inward towards the arm. And it's kind of interesting the way that you're sitting in the centrifuge. You're sitting sideways to that arm. And so when you pull G and the pod starts to gimbal, you're gimbaling like this. And although you're sitting on your side, the sensation that you get is that you're being pushed into the seat. If we didn't have you at G, that you would basically fall sideways, if you will, out of the seat. So the G force actually helps keep you in the seat. But the sensation that you have, like I said, is that the force is coming from your head to your feet during positive G. And some of the interesting things that happen with that, and pilots experience this as well when they're pulling G in airplanes, is that things happen to your physiology. So blood starts to pool or to collect in the lower extremities. You get less blood coming back to the heart. Blood pressure at head level starts to decrease. And when that happens, you start getting some visual effects. So depending on how fast we get you to G, if it's relatively slow, there's some symptoms that you start to experience. And so one of those is that vision starts to decrease. And that kind of differs between individuals. Some people, it's your vision collapses in, and it's like looking down a circle that's slowly collapsing in, and then finally gets to a point where you can't see. And when you get to that point, that's called blackout. So you can't see what's going on, but you can hear what's going on. And typically that's people yelling at you that you need to do something to prevent that from happening. Because the next step beyond losing that vision is that you'll actually lose auditory monitoring capabilities. And then beyond that, you're unconscious. And so we don't want subjects to be unconscious, just like we don't want pilots who are in flight to be unconscious, although that does happen at times, or can happen. But we do some things to protect the pilots. So before that individual goes in the centrifuge, they're wearing some protection equipment. So the pilot has a anti-G suit, looks like a pair of snow pants with bladders in it. Matter of fact, I said, it's really great. I said, probably for sledding, if you could actually inflate the bladders, go out and it probably provide you with some protection if you got bounced off the sled onto the snow. But that inflates during G. So as the G-force increases, the pressure inside of the suit increases. And then it increases to a maximum pressure of about 10 psi. That's a pretty good squeeze. We don't even come close to that. They put a blood pressure cuff on your arm and inflate that to a couple of 100 millimeters of mercury. So that's about approximately, not quite, but about 4 psi, just to give you some comparison there. So they have an anti-G suit that inflates, and that's basically squeezing the pilot like a tube of toothpaste. So the G-force is forcing the toothpaste to the bottom of the tube, and our job is to force the toothpaste to the top of the tube. By the way, pilots don't like it when you refer to them as a tube of toothpaste. The other thing that they do is called an anti-G straining maneuver. And the anti-G straining maneuver is tensing the muscles of the lower body, abdomen, buttocks, legs, and then they're taking a breath in about once every 3 seconds, and then they're increasing the pressure in their chest, and that's forcing that blood back to the head. So the combination of the suit forcing blood back, you're straining, forcing blood back to the heart. And then the increased pressure in your chest, which actually forces that blood now back up to the brain, keeps you conscious, and then it also helps you do well on cognitive tasks like flying the airplane. And so all those things together, and we have to basically train our test subjects and our pilot population on how to do the anti-G strain maneuver to the point where it's really just second nature. You start pulling G and you start straining. So what happens if you get behind the strain maneuver? And you didn't start straining at the point you start pulling G? Well, all those things that I talked about, some light loss occurring, some blackout, and eventually loss of consciousness, those types of things can occur. So that's basically how we get somebody set to go in the centrifuge. All of our profiles that we use are run by the computer, so it's a computer controlled operation. And then the subjects, of course, before they participate in an experiment, are briefed on what the parameters are. And if there's some training that we need to do, so maybe they're doing an air-to-air combat simulation task while they're pulling G, they're trained to do that. Or if there's some cognitive tasks that we're doing, they're trained to do those tasks as well. So when we're running experiments, it's unlike the pilot population who are uninstrumented. We have a lot of instrumentation on these folks. So we might be looking at heart rate and looking at EKG. We might be looking at things like brain tissue oxygen saturation. We might be looking at things like how much air are you exchanging in your lungs by measuring the amount of flow coming into the mask and the volume of air that you took in. We might be looking at things like a respiration rate. We might be looking at things like how long did you hold your breath? If you hold your breath too long, that's bad. If you don't hold your breath for a long enough period of time, that's bad. So it's kind of like Goldilocks and the Three Bears. There's just that just right point that we're trying to get folks to in terms of that air exchange when they're doing the anti-G strain maneuver. So all those things put together are basically helping to keep them conscious during the acceleration profiles.
So does some of this research have multiple purposes? You know, if you put a Air Force pilot into the cockpit at the end of the centrifuge arm, or you put an astronaut in there, they can use that simulator like you mentioned, and they can see what the tasks are like under as much real life situations as you can make it, including the pressure and all these things.
Right. And over the years, we've actually helped in aircraft accident investigations. So we can get the profiles off the aircraft that went down, and we can pull that information comes off the black box, and then we can recreate those profiles in the centrifuge. And we've done that in the past, working on various accident investigations, and then providing input back to that individual, the G levels that they pulled, and for the period of time, did that set that individual up to a point where they may have experienced a G-induced loss of consciousness event, where the G-force basically caused them to lose consciousness. And that's really important in trying to create those accidents. You mentioned a little bit about it doesn't make any difference who you have come in and participate, and that's absolutely true. Matter of fact, we've even worked with industry. So we worked with the group out of Blue Origin at one point in time. So civilians in space, and it was early on in their design process for their spacecraft, but we also do work with other groups within the DoD. So we're really very, very closely with our neighbors one building over, the Navy Medical Research Laboratory down the hall from us. And we basically do a lot of collaborative work with the Navy on projects. Matter of fact, on any given day when you come into the facility and you see people collecting data, it's really difficult to know who's actually in the Air Force and who's in the Navy, because we work that closely together. And we work together as a team because we both have the same issues. We're both dealing with pilots. Doesn't make any difference what branch of service you're in. The G-force doesn't really discriminate, or the altitude doesn't make any difference. It's really physiology of humans and how they respond in those environments. So we do a lot of really close work with the Navy.
And something you may do with the Navy as well, the centrifuge for sure, but we know another part of your job is sucking the air out of the box, as you put it. So that's the
That's right.
altitude chamber. So I assume you do work with them there. And following that thought, what kind of work is done in the altitude chamber?
Yeah, so part of our mission is research. So I talked a little bit about that, but the other part of our mission is equipment evaluation and test and evaluation. And so things like next generation aircraft. So our next generation trainer, we've had an opportunity, both groups, very interested in how the breathing regulator works and how somebody breathes on that and how easy or difficult is it to breathe, because some of those technologies end up in both of our weapon systems. We've done some work for the F-35 group as well. And again, we're looking at breathing regulators and how do those work and what improvements can you make to equipment over time? What might the next generation look like? And you do that not only in the centrifuge, but the altitude chamber as well. Matter of fact, in the altitude chamber, we're making sure that those breathing regulators are providing the amount of oxygen needed for a given altitude. And it's not just the level of oxygen. At a given altitude, say above 40,000 feet, we need to have some positive pressure associated with that 100% oxygen that you're breathing, just to be able to force the oxygen into the blood at those types of altitudes. So both of us work together as teams and evaluating the equipment. Next gen helmets, we've done some work with those, and we're going to do some more work with those in the future. Automated backup oxygen systems, how do those work at altitude, and do the sensors work the way that we believe that they should in providing input in?
I'm curious though too. So you mentioned the physiological impacts of pulling G. So when you go higher in altitude, you kind of started broaching it. What
Oh, yeah.
happens to the human body as you go higher and higher and higher?
Yeah, so what happens is if we're not giving you supplemental oxygen, is that the oxygen level of the blood decreases over time. So what does that mean? Well, what that means is that you have less and less oxygen coming to the brain. And when you have less oxygen to the brain, we don't process information very well. And so there's a couple of different tasks, and we use these tasks basically to emphasize to pilots just how dangerous and how insidious a hypoxic event is. So hypoxia, basically, all that means is it's the medical term for we don't have enough oxygen to the blood. As you're at altitude for long periods of time, you see the oxygen levels continue to decrease. And then if you're doing a task, and so some of the tasks that we have pilots do, sometimes we give them the shape sorter, the one that you give little kids. So it's the square goes in the square hole, and then the circle goes in the circle hole, and that star goes in the star hole. We'll give them that task to do. And then we'll ask the pilot, we'll dump all the shapes out and say, can you put those back in for us? And they always look at you like, yes.
Seems simple enough.
Right. So they start working on the task. We've already taken them off oxygen. Well, pretty soon, their oxygen levels have reached a critical point for their brain to actually process information. And now the pilot's trying to put the square peg in the round hole or in the star hole, and it won't go. Even if you hold it in place and you pound on it with your fist as hard as you can, it still won't go. And then we'll put them back on oxygen, and then we'll ask them, well, how did you do on that task? And they go, great. Do you have any problems at all? No. You able to get all the shapes in? Yeah. Then, well, we're going to show you your video. And then they'll look at the video, and they're just amazed that for that period of time, they were unable to do that. A very, very simple task. Another task that we'll give them is a deck of cards. And this really has to do with how we store information cognitively. And so we give them a deck of cards, and we say, what we want you to do is to pull a card up, look at it, tell us what it is, and then show us the card. So Queen of Hearts, 3 of Clubs, 4 of Spades, 2 of Diamonds, 2 of Diamonds, and we'll go, what was that card? 2 of Diamonds, 2 of Diamonds, and then we'll put them back on oxygen again, and then we're back Queen of Hearts, King of Spades, Jack of Clubs. And then we'll ask them, how did you do on that? Great. And then we show them their video, and the pilot just stands there looking at it and goes, I was so stupid. I know those cards. Why did I say that? I said, you said that because the oxygen to your brain was so low that you were unable to recall that information that you've got back in there in the storage area part of your brain. You couldn't pull that information forward. And so the last thing that you remember was that last card that you pulled before that information. You were unable to pull that information up. And they're just amazed. And I said, can you imagine being in the airplane and then not being able to do the task or believe that you're doing the task fine and you're not?
So bringing this all to a head then, or really to an end, after this 45 years you've had serving with the Air Force, whether it be a civilian, enlisted, researcher, all the above, you have to have some amazing advice for the future workforce. And we know a major part of your story too is being a mentor and having amazing mentors. So we know there's a story that may illustrate kind of this point with one of your first students that you actually had as a mentee. Using that as kind of context, how did that not only shape you as a mentor, but how can this help people looking to join a similar field to you in the future with the advice you have?
One of the really cool things about Right Pat is we have a program. Well, we have several programs for different levels of education, but one of the programs we've participated in quite a bit is takes high school students in and basically matches those high school students up with researchers. And this is the Right Scholar program. And I'll tell you what a great program. If you could see the resumes of the individuals who apply for this program, it is amazing the things that they've done already in their life and those life skills that they've developed, as well as the education level that they have. Most of those individuals have grade point averages of about 4.6 to 5.0, which means that you're taking a lot of additional difficulty courses as part of your high school education. And so I remember the first Right Scholar student that I had. She came in, she was very shy. And her first day, she said, um, do you know what I'll be doing this summer? And I go, yes, I do. I said, this summer, I said, you're going to teach test subjects for the centrifuge how to fly the F-16 flight simulator. And her eyes got really big and she says, well, I can't do that. And I go, no, you can. I've read your resume. I said, you are scary smart. Matter of fact, she had aced the ACT and the SAT, both. And so I said, she goes, well, I don't know how to fly the F-16 flight simulator. I said, right, not today. I said, but one of the things we're going to do, I said, is I'm going to work with you and I'm going to teach you how to fly. I'm going to teach you all the ins and outs of how you keep the airplane in the air, some aerodynamics. And then every day for the next, oh, I don't know, maybe 2 months, what I want you to do is spend 2 hours a day flying the flight simulator. And she says, well, let me get this straight. She says, so for 2 hours a day, you want me to come in and you want me to play video games? I said, well, I like to think of them as, well, high order cognitive tasks. But hey, if video games works for you, yeah, pretty much. That's what I like to have you do. And she goes, well, how cool is this job going to be? And I go, oh, this is a really cool job. And so in less than a month's time, she was basically trained up and she was ready to start training test subjects. So she trained all of our test subjects for one of our experiments on how to fly the F-16 flight simulation. But while she was there, and usually I have a meeting with the students, probably their second week after they get done with their in processing. So I asked her, I said, so what do you want to do when you grow up? And she goes, I don't know. I said, you don't have any idea what it is that you want to do when you grow up? And she goes, no, I'm still trying to figure that out. And I said, okay. I said, so what I want you to do this weekend, this is on a Friday. I said, so what I want you to do this weekend is I want you to go home and think about what it is that you want to do when you grow up and then come back and tell me on Monday. She says, you want me to go and figure out what I want to do when I grow up over the weekend? I go, yeah, that's your assignment. She goes, and you need to know Monday. I go, Monday, yeah, yeah. So one day she comes in and I said, so do we figure it out? And she says, she says, I've always been interested in medicine. And she says, but I really don't know a lot about medicine. And I said, okay. I said, so how do we fix that? And she goes, I don't know. And I said, well, I'll tell you what. I said, I know a lot of people in medicine. Matter of fact, I used to work in medicine. So I have a lot of contacts. I said, why don't I call over to the medical center at Wright Pat and see if I can get one of the docs to have you shadow him for a day. And she goes, oh, really? She says, like, you think they'll let me shadow him? I go, absolutely. I said, we love talking about what it is that we do. And it doesn't make any difference what career field it is. It could be medicine, it could be science, it could be whatever. Pick a career field. You will find somebody who wants to talk to you about what it is that they do. And what better way to figure out what it is that they do, and if that's something that you're interested in, than to shadow somebody. And a lot of folks, I think, that are kind of in that situation right now where you're trying to figure things out, find somebody who does that and work that out so you can shadow them. You probably know somebody who knows somebody who knows somebody who can get you in to do that. So you don't even have to come up with that individual yourself. So anyway, I set that up. She spent a day over at the hospital and she came back and she was extremely excited. She goes, they want me to come back. Can I come back? I go, absolutely. And so she was actually interested in the anesthesiology area. So she teamed up with an anesthesiologist. She was in the surgical suite. She got to see what anesthesiologists did, spent the entire day with them, did 2 or 3 cases during that day with the anesthesiologist, and came back. And she says, I'm going to be an anesthesiologist when I grow up. I said, great. So many years go by, probably over 15 years, probably about 15 years. I'm TDY to Singapore. I'm at the hotel in one of the little restaurant areas. And this gentleman comes up and he says, you don't know me. He says, but you know my daughter, Amanda. He said, you had her as your first Wright Scholar students. I go, oh yeah, I remember her. I said, yeah. I said, matter of fact, I said, she was a great instructor for the F-16 flight simulator. And he kind of laughed and he says, he says, I never had an opportunity to meet you. He says, but I always wanted to thank you. And I said, for what? And he says, Amanda was one of our 3 children who had no idea what she wanted to do when she grew up and was driving my wife and I absolutely nuts. And we told her, you're going to be a sophomore this year. You need to start thinking about what it is that you might want to do. College is just around the corner. And he said, you sent her home with an assignment over the weekend and she figured it out. We spent years trying to get her to figure it out. And he goes, why is that? And I said, because I'm not her parent. I said, trust me, I have that same experience with my kids when they were younger. And I said, so somebody else says something that seemed to have more weight than if your parents were to say that. So I said, well, I'm glad that worked out. I said, so what is she doing today? And he said, well, she went to Case Western, did her pre-med, and went to medical school after that, and now is at Stanford finishing up a residency program in anesthesiology. So that little bit of time and really hardly any effort, right, on my part to kind of give her some guidance on what to do and to get her to shadow somebody basically ended up being a career for her down the road. And, it's one of those things, and I'm just putting this out for the folks who are mentors out there. You don't realize it at the time, but we really can have a pretty significant impact on somebody's life. And an extremely rewarding experience if you've not been a mentor. I really encourage folks to do that. Matter of fact, personally, I think that as professionals, we really have an obligation to mentoring and providing advice to the folks who are coming up. Those are the people who are going to be taking our place when we retire. So I guess that's all the advice that I have there, but just passing that on. So if you've not been a mentor yet, look into that. It's a great opportunity.
Well, we appreciate that advice, and I bet there's a lot of parents and guardians out there that would like to have their kids go through your boot camp and figure out what they're going to do for the rest of their lives. And hey, all the better if they're anesthesiologists, right?
Right. I may need them someday, right?
Oh, we all may, and that's exactly what it is. All of the inspiration we do for the STEM is we know that we're going to need them someday, whatever problem they're solving in the field. But Dr. Tripp, thank you for joining us today. Thanks for your service. Thanks for explaining, what the big box is and what the centrifuge is as you spin people around. And, someday we're going to get Ken in there.
All right.
Trust me, I can't say from experience. If you guys are fans of Kings Island, I was blacked out on one of the rides there, so I'm sure I'll do great in the centrifuge.
Okay, great. All right.
So thank you again. It's been a pleasure to talk to you. We'll look forward to having conversations in the future.
All right. Well, thank you. Bye now.
Make sure to follow us on social media at Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.